All right, well, anyway, let's go ahead and get started. Moving over here. All right, so we're gonna go ahead and finish up with this one here. I think we were on, all right, we finished this one yesterday. So I have this one, two more. We'll use this as our review and then move on to what we're doing today. All right, so again, looking at these parentheses, a lot of times they're not really doing anything. Sometimes they are making a difference. But like in this case here, if we look at what's going on with each of these groups, we have a plus and a plus. So if we're adding a group that doesn't really change anything, and I think a lot of people would just think of it like taking away the parentheses. But remember, we're adding this group, we're adding this 8 and that I together. So that means we add the 8 and we add the I in there. And this one here is also adding. So when you add here, so if you add a negative, you're still just taking it away. And add this one here too. So add that 8 and I. From here, you just go through all of your terms and combine your like terms. So -7 plus 1, so that'd be -6. -6 plus 8 is 2. And remember, you got to put them in the right order. When it comes to complex numbers, you have to put the real part first. So even though in this case it gave us I first, I know some people might want to do something like this, but be careful because one of our objectives is to put the numbers into the correct format. So I always get people that will, kind of bring that up in things like, oh, but it's the numbers are all there, the numbers are right. In using commutative property, well, okay, yeah, technically you're right, but then the goal of the lesson is also to write complex numbers in the correct form. So when you write them in the correct form, it's going to have to be real number, then imaginary number. And then we're done with that one. I'm going to move on to number 12. Oh, good, everyone's showing up. I'll probably do my announcement again later. But I think first hour is getting pretty good about this showing up. I think it's my second hour that's kind of getting lower in attendance. All right. So this first group, it's not really doing anything. So it just sort of stays the same. Because there's nothing in front of the parenthesis that would cause this to change. And here again, we're adding a group of 2I. So actually, we don't really need that group. I mean, if this was written up to here without the parentheses, it would pretty much just be the same thing. But maybe these numbers all came from a different place. Sometimes it'll look like A plus B minus C, and then it'll tell you substitute this in for A, that in for B. So sometimes you do need the parentheses, but in this case, no. All right, now this is the one thing that I'm telling people to watch out for, because when I'm grading homework assignments, this is usually the thing that if someone gets it wrong, this is what they're doing. So I'm gonna go ahead and make this number like that. All right, so now look at it and what's going wrong with this, because it is wrong, but the question is, what is it? Okay. So again, this is what I see that's very, very common. For as long as I've been a teacher, I always see this one, and that is they give the negative to the first one, but they don't give it to the second one. You have to give it to both of them. These two are grouped together. And don't forget what this means. This minus means we take away 2 and we take away the -6i. If you take away a negative, it's not going to be negative anymore. It's going to be positive. So that's why this changes as well. An easier rule to remember would be something like if you have negative like this, you flip the signs of everything in the parenthesis. So just take the sign and flip it, everything in there. And then from here again, we're going to start with our real numbers. So -2, -8, put them together, and I have -10. Now I'm going to go through and look at my imaginary terms. So looking for the imaginary numbers, 4, 2, and 6. So I'm going to go ahead and add those together. And there we go. It looks like we are done with that one. Not bad. All right, moving on, I guess. All right, I'll give you a second or two to copy this one down. All right. Whew. Oh, man. All right, now, same thing, we have a first group. And usually the first group just sort of stays the same. It doesn't usually change all that much. But let's go ahead and 1 plus 5i. And we run into the same problem here where we have negatives. So negative or a double negative. In this case, again, we're taking away that negative. So if you take away the negative, it becomes positive. And again, don't forget to give it to both of these numbers. So if this is negative, it also needs to change its sign. So everything in that parenthesis needs to have the sign reversed, changed. And like I said, this is not a particularly tough one. From here, it's just like regular algebra, combining like terms. So let's see, start with the real numbers. 1, 2 is 3. 3 plus 8 is 11. And I also have 2 imaginary numbers, 5 and 2. So 11 plus 7i. All right, we're done with that one, and let's move on to the last one. So this first one has nothing going on with it. There's no negative or anything in the front, so we can go ahead and just leave that as is, sign-wise. And this middle one here, again, we're subtracting the whole group. So this -8, that's being subtracted. This -4i, that's also being subtracted. So again, flip the signs of both items in that parenthesis, or if there's more of them, like sometimes there can be 3 things in a parenthesis, just flip all of them. Now in this case here, we're adding these numbers. So again, we're adding -6, which is just the same as minusing 6. And we're also adding 8i, or positive 8i. If we add a positive number, it just stays positive. And there we go. Now we have nothing in parentheses left, which is good. From here, just add your like terms. So 7 plus 8 is 15. 15 minus 6 is going to be 9. And I have -4i and +4i, so they cancel each other out. That would be 0i. 0i plus 8i would just be 8i. Then, and that's it. Okay. All right, and moving on to the next one. So we're gonna multiply some of these. So let's see what it says. When multiplying square roots of negative real numbers, begin by expressing them in terms of I. So it wants us to, okay, so when we were simplifying the radicals with the imaginary numbers or simplifying complex roots, what was it called? I think it was just simplifying complex or simplifying imaginary numbers. It's going to be the same thing. So anytime you have a negative.
Attention, high school custodians or someone, can someone load up the homework boxes into a truck that's sitting outside? We need to get a move on. Thank you.
Okay, so just like simplifying radicals with negative numbers, take out the negative number first. We could probably also, well, okay, so in this case, we don't need to take all of them out because we're going to end up multiplying them anyway. I'll show you what I mean. So first thing I want to do is we have -4 under the radical. So we think of it as -1. Okay, so I'm just going to write the whole thing out. -1 times 4. Now we can see that the negative is by itself. We can evaluate that -1, take the square root of -1, because we know that's just going to be I. Now, I'm trying to think of what would be a better thing, because here I can also take out the 4 as well, right? Because we know the square root of 4 is going to be 2. But let's wait on that. Let's wait on that until we see what's going on. And I'm not because, okay, well, let's see. If we were to evaluate it, then we'd have a whole number times a radical number. And I'm trying to think if that would be easier for students or more difficult for students. But I think for now, I'm just going to say, because it just says begin in terms of I. So let's just worry about the I for now. I times root 4 times, and I'm going to do the same thing with this one. I'm going to take out the negative. Take out the negative by replacing it with I. So I times root 8. And like I said, you could reduce or simplify these, but I think it'd be better to just leave it like that for now. Now, when we multiply them together, remember, just like the other time. So this is all one term. So when we multiply these, we have to multiply outside number to outside number and radical to radical. So I times I will be I square. And this should be root 32. Now I'm thinking we should simplify root 32. And like I said, you could probably simplify it before, but I think that might add a layer of confusion on there. So I'm just going to stick with it like this for now. So I square, now I don't have that chart with me, but on one of the earlier lessons, I think it was Monday's lesson, we had that lesson where you needed the chart, and with that chart, you would get the number that it was equivalent to when it had different powers of I. You could use that, or again, remember that this just means root -1 squared, so you get -1 times, and I'm going to break 32 into two numbers, and I'm going to try to look for a square number, or the biggest square number I can get, which in this case is going to be 16. And I'm going to take the square root of 16. Now it would be, the square root of 16 is 4. So if I take out a 4, it's going to be 4 times -1. So -4 times 2 times root 2. There we go. So like I said, it's a bit of a weird thing, but it does get confusing because sometimes these negatives will cancel each other, or sometimes, like in this case, it's still going to be a negative. All right, but I think we're nearing the end of all these imaginary number stuff going on. So I know even during a normal school year, I always get students that are like, oh man, this is really different. This is really, you know, new stuff, and it has like kind of special rules and stuff. So I understand that. But anyway, next week I'm going to be changing my entire curriculum. So hopefully we're going to go with something that's a bit easier to follow, I guess. I don't know. I'm going to try it out. But we'll see how it goes. But I want something that the packets are easier to work with at home if you don't have help. So, or if you can't make it to the videos here. So we'll see how that goes. Anyway, let's go ahead and do this one here. So root of -6 times root -6. Now, just because you don't see the little dot in there doesn't mean that it's not multiplying. It is still multiplying. But just because we don't have that dot in there doesn't mean it's not multiplying or anything like that. So let's go ahead and take out I first. So I root 6 times, and I'm going to put the dot in there too, just so there's no confusion. I root 6. So again, we took the negative out, replaced it with I. Now we can multiply them together. So again, outside number to outside number. So I times I is I square. And then multiply the radicals together. So we get root 6 times root 6. So we get root 36. We can take the square root of 36. That would just be 6. And we also can take the imaginary number to the second power, or I square. And again, I square is just -1. So -1 times 6 is going to be -6. So there we go. That's our answer, is going to be -6. Now, if we look at the directions, it says begin by putting them in terms of I. What happens if we don't put them in terms of I? So in other words, does this make a difference? Because we know in math sometimes you can do things a different way and get the right answer still. So is this one of those things that we can do something different and still get the right answer? Well, what if we don't put them in terms of I? What if we were to put them as -6 times -6? What if we were to multiply them first? Now this doesn't quite work out because if you remember the order of operations, the PEMDAS, it says you should take care of parentheses, which we don't have any. And then it goes to exponents. Exponents. Remember, the square root symbol is the opposite of a square, an exponent. So what if we do the multiplication before the radical, which again is the same as the exponent in terms of order of operations? Do the multiplication instead of the exponent, we get positive 36, because negative times negative is positive. And if we take the square root of positive 36, we get positive 6, which again is not the same thing. So we do have to take the I number out first. And again, what's kind of weird is like when you talk about PEMDAS, people know that this stands for multiplication and division, which are the same step. And then you also have addition, subtraction, which are also the same step. So just because you see a subtraction before an addition doesn't mean you subtract first. But there is supposed to be a radical right here, so that would be more like PERMDAS. But again, we don't have radicals in the normal thing in the normal order of operations because it's not really that common. But again, radicals are part of the E. So that's why you have to take care of the radicals before you multiply them together. Okay. And how many do I have? Maybe we could go up to about there. Or until the time comes. Okay. So now we have two complex numbers. So remember, a complex number has a real part and an imaginary part. So here we have two groups. Now, if you remember from the last one when we were adding and subtracting, the groupings made a difference sometimes if you were subtracting them. But when you have multiplication n groups, that is going to change. It's going to change a lot. So I think we're going to start off with some tough examples now. So quick recap, FOIL, remember, stands for first outside, inside, and last. Okay, it's not really the best handwriting. Again, I'm using the mouse, but actually, yesterday I bought a pad, like a mouse. It uses a pen, like a little tablet thing. Because I bought one and it didn't work, so I had to send it back. So it didn't last very long. Then I bought, I bought this one here, and hopefully it will work. So hopefully the writing will go a little bit faster and all that stuff. The only thing is I'm gonna have to get used to it once it gets here. Okay, so FOIL it out. First numbers, so 2 times 8 is 16. And outside numbers, so in this case here, I have 2 times negative 7i. And again, be careful with your signs when you're using FOIL because the signs will make a difference. 7 times 2 is 14 and I. Then inside numbers, 3i times 8, 3i, so 3 times 8. 3 times 8 is 24. I, and they're both positive, so it's going to make a positive number, so plus 24i. And fourth step is to multiply the last number, so 3 times negative 7. So in this case, I have a negative number, so put that negative there. 3 times 7 is 21. And I times I is I square. Now, if you remember when we were multiplying numbers with radicals, things like this did happen where if you multiplied two like radicals, then it would just become the number. Like if I multiply, say, root 2 times root 2, it becomes root 4, which is just 2. Same thing's going to kind of happen here. But luckily, there's kind of an easy way to do this. But anyway, let's go ahead and combine like terms first. So I know whenever I do problems the first few times, I usually write every single step. Then after that, I kind of, hopefully once you kind of realize why we're skipping that step, it becomes a little bit more easy to understand. So 24 minus 14. So 24 minus 14 is going to be 10i. Then we have negative 21, but I'm going to evaluate this I square because remember I square is negative 1. And don't forget this is 21 times I square. So when I evaluate the square, it's still going to be times. We're still multiplying them together. Now I have -1, and when I multiply -1 times anything, it's just going to switch the sign. So it's -21, but when I evaluate the square, it just becomes +21. And again, there's kind of a middle step that sometimes I'm going to skip it, only because writing it's going to take a little bit longer doing it this way. If I was using the board, the Promethean board behind me, it wouldn't be an issue. You know, I could write that line just as fast as I could write it on a whiteboard or something. But if I want my handwriting to be good on this, I have to kind of move a little slower. But anyway, now I have two real numbers now. So I'm going to combine those. So 6 plus 1 is 7, and 2 plus 1 is 3. So I get 37 plus 10i. And there we go. Not too bad. Okay. Now again, with this next one here, I'll sometimes get this one too, so I'm going to do it the wrong way first. So if you remember from properties of exponents, sometimes this there's a lot of different things going on, and I know it's confusing, but when you have a group, when you have numbers grouped and you square the group, that means you have two groups. It does not mean something like this. So sometimes people make the mistake of distributing the power. So in this case, we have the power of 2 and we distribute it. So we square 3 and square -4i, so we get plus 16i squared. Okay, and again, that's not really right. But let's just see how different, when we do it the right way, how different it actually will be. So I'm going to go ahead and start out by using my 2 parentheses, or as I call it, the double bubble. I don't know if that candy is even still around. I'm sure you could find it, but the only place I know where to get it is the parades. Somehow, like, the parades, when they come around, they have like all the candy that you never find. Like those Laffy Taffies, like I don't see them anywhere, but then when you go to the parade, they're like every other float's giving them away. Or those watermelon candies, somehow you find them at like, it's like a watermelon candy, but rather than being wrapped at both sides, they're wrapped on one side and then they have that bow on top. Those are like so hard to find. I don't know where people get them, but they're pretty good though. But I guess that's what makes them special when you find them. Okay, so multiply the FOIL, so 3 times 3. Outside numbers, 3 times -4, so -12i. And let's see, -4 times 3 is 12. Don't forget the I. And in this case, I have a negative times a negative. So negative times negative will be positive. 4 times 4 is 16. I times I is I squared. So remember, when you factor these things, that this last sign really plays a big role in trying to factor them out when you're trying to separate the numbers again. And that's why, because negative times negative can also be positive. But in this case, it's going to end up changing. So 9 minus, in this case, 12 minus 12 will be 24i. And I could just change this to -16, which again, that's the shortcut. Anytime you see the I square, just change the sign in the front and that's how you fix it. But again, I don't like skipping steps the first few times, at least the first few times. But we end up with I square being -1. So when I multiply -1, I end up getting -16. Oops, I almost forgot this I here. Good thing I'm looking out for myself. 9 minus 16, so I got to put the real number first. So 9 minus 16 is -7 and 24i. Okay, there you go, a lot of steps. And again, this looks way different than this. So again, you're not distributing the exponent, you are foiling it. You have to write the whole thing out. And again, this step here in the middle, you could just skip that one sometimes. Okay. Oh, now it looks like we're going to start with some easy ones. Let me just look really quick. 1, 2, 3, 4, 5, 6. Okay, we'll probably go up to about there. And then we'll be done for today. All right, so same thing. Well, in this case, it's kind of a multiplying, but it's more like the introduction slide. Right, we want to take out the I first. So by putting the I here, we take out this negative, so there's no more negative. Remember, you cannot take the negative, you cannot take the root of a negative number, but if you take it out as I, now we can take the square root like it was a positive number. And again, that's one of the reasons why we have imaginary numbers, so we don't have to stop working on something just because we run into something we can't do. And that was it. Okay. Same thing with this one here. Let's take out that negative first. So I root 9. I think you could probably do both of them at the same step too, and it wouldn't really affect anything. But in this case here, you notice that I am going to run into, well, it would be better to just write the whole thing out. So take out the negative, so you get 2i root 4. And now you can take the square root of these numbers here. And this one's kind of it looks a bit weird because when people see the dot, that tells them it's multiplication. But if you remember in algebra, sometimes just having two terms next to each other means multiplication. So all of these are being multiplied. I times root 9 times 2 times I times root 4. So everything's multiplied, but we just don't put dots on everything. So I'm going to go ahead and evaluate this. So we get 3i times 2i and times, in this case, root 4. So root 4 is going to be 2 if I take the square root of 4. Now we can multiply all of these together. 3 times 2 times 2. Now remember, in multiplication, you don't need like terms. 3 times 2 is 6. 6 times 2 is 12. There you go. Now this one does not have an imaginary part. It does not have an I variable. But again, you treat these just like you would any other variables. If it was like K or N or X. But we do multiply the imaginary parts together also. So I times I to the 0. All right, don't need to get too confusing. But yeah, that last one is I to the 0 because it doesn't have one. Now, just multiplying these two, I get I square. And if you remember, anytime you have an I square on a term, so in this case, the coefficient is 12, you just reverse it. Reverse the sign. So if it was positive, it's going to be negative. Or if it was negative, now it will be positive. All right, there we go. With that one, I think these next ones are also going to be a little bit of a shorter one. All right, give you a second or two to start writing some of these down. All right. Same thing with these ones. Let's get rid of these negatives. So when I take I out, there's 4 already outside. So I'm going to just stick that I right there behind the 4. Root. Oh, sorry. I'm already getting ahead of myself. Now in this case here, it looks like I have a non-square number, or a number that is not a perfect square. So again, we do the same thing. We think of a set of numbers that would have a square number we could take out, that we could factor it to. So if we thought of something like 2 times 10, okay, that's not going to help because neither of those are square numbers. But 4 times 5 will work out. So that's what I'm going to do. 4 times 5. Okay, now we can start evaluating the roots of whatever we can. So 4I times 3 times, actually in this case here, I'm going to take the square root of 4. So square root of 4 is 2I times root 5, because this 5, we can't get it out. It's not a square number. We can't simplify it anymore. So we're just going to have to leave it in there. And again, all these terms are being multiplied together, so we can start with the coefficient, the numbers in the front. So 4 times 3 times 2, so this is 4 times 3 is 12, times 2 is 24. I times I is I square. And then we can't really do anything about this. So I'm going to go ahead and just leave that there. And oh, we're not quite done. There's one more thing we can do, and that is to take care of the I square, because again, anytime you see the I square, just reverse the sign of the number that it's on. So negative 24 root 5. And now on to number 4. So this is another one that kind of gets forgotten too, the distributive group. So just multiply both of those together. I mean, sorry, multiply both of the numbers on the inside by 4i. So 4 times 3 is 12. I And then 4 times 3, in this case here, 4 times 3 is, well, 12 again. But this one has I already, so I here, I there. So I'm going to have to multiply them together. And again, I run into that problem that there is an I square in there. But that's easy to fix. Remember, I squared just means -1. So just reverse the sign. Now it's -12 and the I square is gone. I'm going to just switch places on these numbers. So just move them around. Because again, we want to make sure that these numbers are in the right format. The format of complex numbers. And that was it. All right, moving to the next one. Ooh, that number 5 one, if you look at it and remember from Algebra 1, you might call that a difference of squares. Is that what it was called? No, I think difference was when they were both negative. But you notice that in each of those parentheses, they both have 2 and a 3i, but they are different. I know there was a special name for that, but now it's like just gone. Oh well, I guess 7 months in quarantine will do that to just about anybody. I guess technically we're still in quarantine because there's nobody else in here. All right. Let's go ahead and start this one. So we have 2 binomials, so we're going to have to use FOIL. So 2 times 2 is 4. 2 times -3i. So in this case here, 2 times -3i. So -6i. And inside number is 3i times 2. So that's going to be plus, and then 2 times 3 is 6. I. Then move this over. So that would be, multiply them. So positive times negative is 9. And I times I would be I square. I just had a really weird space out just then. So when you have a difference in your parentheses, so 1 positive and 1 negative, this is what's going to happen. Your middle term is going to cancel out. So 6i minus 6i. 6 minus 6 is going to be 0, so you don't have anything. It cancels out. It's gone. Just like saying you have $6 and you spend $6. Gone. And just because something different happened, I'm going to just write this next step out. So again, I'm going to evaluate I square as -1, just so that way we don't, confuse the signs somewhere. So 4 times -9 times -1. So I'm going to multiply these two together. So that's going to be negative times negative is positive. 9 times 1 is 9. So 4 plus 9. And I have no more imaginary numbers. It's keeping it real now. There you go. So we managed to keep it all real. And I said that too. Remember when we're solving equations, I said sometimes you have real numbers that become imaginary and imaginary numbers that become real. Although most of the time you will have more imaginary numbers becoming real than the other way around. Okay, now on to number 6. So this one's pretty easy. I have a group. They put it in. I'm pretty sure they put it in a parenthesis to remind you, because if the parenthesis wasn't there, some people just might multiply it by 8i. But anytime you have a sign on a number that you're multiplying, that sign has to go with it. So in this case here, -8 times -5 is positive 40. And same thing with this one. Don't forget to make the negative go on to both of them. So negative times negative is positive. So negative, so it'd be 8 times 6, which is 48, I think. Let me think about that. 3 times 8 is 24. So double that, you get 48. Okay, I guess that works out. I times I gives me I square. And again, I'm going to go ahead and just reverse the sign to get rid of that I square. So this is negative 48 instead. Now I want to put it in the proper form of complex numbers. So I'm going to make my real number go first. So just switch it. And again, when you switch it, make sure you take the negative with it. So this is a negative 48 and this is a positive 40. So make sure they stay the right sign. All right, I'm not sure if we have enough time to go to the point where exactly I wanted to go. So I'm gonna kind of scout ahead and look for some of these pages of something that would be a little bit better for us to do. Which of these would be better? Okay, so I guess we're gonna do this one then. I mean, this is a little bit more complicated, and that way when we do the review tomorrow, I can have a few more that are a little bit easier, so that way we can kind of ease back into it again. Well, actually today's Thursday, and I don't know if we have a lesson tomorrow. Which reminds me, I have 2 more announcements I want to make. But we'll do these ones and then I'll go over the announcement. All right, so let's go ahead and use our FOIL. So -1 times 5 is -5. -1 times -6, so that's going to be positive 6i. Inside number, so plus, and then 5i times 5 is 25i. And 5 times -6 is 30, and I square. All right, so I can evaluate this and this. I'm going to take care of both of those things now. So -5. Combine these 2 things, I get 31i. And I'm going to switch the sign on this for the I square, reverse the sign so it's now positive instead of negative. And now I'm going to go -5 plus 30, which -5 plus 30 is 25, 31i, and now it's in the correct form. And that's it for that one. Last one, I guess, we'll make this one the last one. We're still gonna have to do our FOIL. And again, watch out for these signs. These signs do make a difference and you do have to multiply them. So -3 times 7, so this would be negative 21. Negative times negative is positive. 15i. Inside numbers, negative 4 times 7, so that'd be 28i. And last number, so negative times negative, so this is going to be positive 20i squared. Oh boy, looks like we got some stuff to put together. All right, so for now I can leave this the same. And 15 minus 28. So let's see, this is a kind of a weird one to do in your head. So what I'm going to do is I'm just going to take 28, which is the bigger number, not the greater number. 28 minus 15 is 13. And since the sign is the sign on the bigger number is negative, it's going to be negative 13i. It's just a quick trick on how you add integers. Right, just take the one with the higher absolute value, or as I like to call it, the bigger number, subtract the smaller number, but take the sign of the larger number. And, excuse me, I square is negative 1, so negative 1 times 20. And now I think we can put our like terms together. So negative 21 minus 20, so that would be negative 41 minus 13i. All right, and I think that's a pretty good stopping point. Let's see what else we have. I can, these are more of the same thing. There's nothing really that different. I don't think there's going to be anything on the homework that's going to be very different than most of these things. So I guess we'll go ahead and stop right here for today. And as for those announcements, let me go ahead and get to those, and then that'll be it for today.